they are independent. So one thing that I want to mention, be careful, you are not using the convolution formula here because there is no assumption regarding independence of these random variables x and y. Okay, you can of course probably share what I did before. It was a good solution, I would say, but it is unnecessarily long. If you want to solve this problem, you can introduce two new variables. Of course, you have one new random variable, which is the sum of these two random variables. So apparently, I have only one. But the trick is to introduce the first one to be x itself, for example, and then take the x plus 1. So I am talking about this formula. So you know that if I want to, so let me write something like this. This is the theorem itself. So if you have u equals to some function, if you don't mind, let me call alpha. Let me write of two random variables x and y, and I have b to be beta of two random variables x and y, so that support of these variables is mapped one-to-one and onto on the support of these two variables. This is in the y plane and this is in the xy plane. If these are the conditions, then if you are interested to calculate the joint probability distribution of these two new variables, u and v, let us say calculated as little u and little v, probably you have seen this. Of course, this theorem can go beyond two variables. It can go to any finitely many variables. So have you seen this in your book? So you can write it as f of x and y, and then here you should write x, let me write like this, as a function of x of this transformation. The Jacobian of this transformation, you could usually write it like this, x and y, u and v. Okay. Exactly the same kind of transformation that you might have seen in your multivariable course. That's the same thing, okay? And this can go beyond two variables. So what is this Jacobian? Do you remember? So this Jacobian is defined in this way. Is the partial derivative of x with respect to u, partial derivative of y with respect to v, and then partial derivative of y with respect to u, and the same thing here, similar thing here, and then you take the determinant. But be careful, this doesn't mean determinant. This means what? Because determinant is included in the definition of the Jacobian, which will be a number, so this means absolute value. Yes? It was not probably very clear from the beginning that this method would apply because I have two variables here, but I'm talking about x plus y only, so that is the marginal function for this. Whenever this happens, this method is still useful. So what you do, you introduce the variable u to be x itself, and then you introduce v to be that variable that you're interested in. Okay? Now let us do the calculation. In order to calculate this Jacobian, I need to express x and y as functions of u and v. So this means that I have to solve this for x and y in terms of u and v. But x is already solved, and if you don't mind, let me write lowercase letters. So x is just u, and what is v? The v is x, which is u plus y. So y becomes v minus that. Yes. Sorry, y becomes v minus. And then I calculate the Jacobian. So the Jacobian of x and y with respect to u and v equal to the determinant. The derivative of x with respect to u is 1. The derivative of x with respect to v is 0. The derivative of y with respect to u is minus 1. And the derivative of v with respect to y with respect to v is 1. If you calculate this determinant, it becomes 1. Yes? So the absolute value of 1 is also 1. So what I can do now, I can say that, okay, f of u and v of new variables, u and v, according to this formula, is f of x and y. But I have to write x and y as functions of u and v, which I have already done. X as a function of u and v is just simply u, and y as a function of u and v is v minus. Okay. But something which is very important, might be that's not emphasizing the group property, and that is the support of your new variables. It's extremely important to appreciate that one as well, because it's really a matter of a lot of contributions. So here, the support of x and y are positive numbers. So if x is negative or y is negative, we have this 0. But I have to see what these conditions impose on u and v. Okay? So if x is positive, x is u itself, so u is also positive. Yes, this is very important. Okay, so x is positive, so this means that u is also positive. But then v, y is positive, y is also positive. So this implies that if v minus u is positive, I want to have them simultaneously, so it means v should be greater than u and u should be greater than 0. If I write it more beautifully, I would prefer to, I don't know, it's not beautiful. I mean, I can probably write it the other way. So this is your support of your new random variables, okay? Otherwise, it is 0. So then you continue. So how did I continue? So I would say that this is the joint probability distribution here. Instead of x, I put u. Instead of y, I put v, because this function is the same function. Its input has changed. Yes, the inputs here are x and y. This function is the same function, but the inputs are these two. So you take them with you and put them here. So what will happen? So it becomes 2 divided by 1 plus x. Let me write it in my head. So this one plus this one is just simply, yes, and then to power 3. Under which condition? Can you tell me? This condition translated itself to this new condition. Okay, so I have to write that one. That's extremely important, yes? And then otherwise 0. Is that right? But of course this is not the answer. Why? Yeah, we want the marginal one, because this is not a joint probability distribution. Yes, this is f of capital V little v. Okay, so that's the marginal probability distribution. So this is why this domain becomes extremely important. Now you understand that. So if I want to calculate, so in principle, what is my question mark? My question mark is this, but I call this V. So I can write it as f of capital V, V. But then you know how to calculate this. You have to integrate the joint probability distribution over on the other variable. So this is my probability distribution for x and y. For u and v. I have to integrate it over u variable. Okay. So this means that let me write it here for you. I need to integrate it over u variable. Okay. And then okay, what are the limits now? The limits is on the total support, yes? Because otherwise it is 0. So then my integration variable is u, but I have to run it from 0 to v itself. But because I have already used this letter v here, so in principle, what can I do? I can run it from z. No, that's the same v actually. Yeah, that's the same v. That's good. So then what happens? This becomes integral 0 to v, and then I put that function. But du. But this I can take it out because there is no dependence here. So this is a constant, it goes out. And then this becomes u. The integral of du is u, but I have to run it from 0 to. Okay, so remember, whenever you want to use this formula, but you have only one variable in your problem, this is a very nice technique to learn. Yes, is that clear? Yes? Okay, so now let us go to the first problem of this session. I think this is problem 2 on page 89. Okay, so problem 2, let me write 2, page 89. So, x is an exponential, x has an exponential distribution of parameter 1 over lambda. And then n is an integer, not only integer, but positive integer. Let me say that n belongs to n, 1, 2, 3, etc. And then they have defined two random variables. This is a random variable with exponential distribution with parameter 1 over lambda. By the way, what does it mean? You don't need to memorize them. So what is the answer? So how can I write f of x here? So you need to refer to the back of the book, and then you see that the probability distribution will be 1 over 1. So this should be like this. The famous ones I have in my memory, but the other ones I have to also refer to this one. And otherwise. So this is the translation of this assumption. When you see this, it means this.
Okay? Is it 1 over lambda?
No, 1 over lambda is for exponential with parameter lambda itself. Yeah, please check it out, but I hope that I can trust my memory here. If it is exponential lambda, then 1 over lambda appears, according to what I saw here. It's always good to double check. I think that's good. Okay. So this is the translation of this one, and they have given you m an integer, which is not given in this problem because this problem is based on the previous problem. In that problem, they have mentioned that m is an integer, and then they have introduced two new random variables. One of them they called L sub m to be the floor of this function, of this random variable. And because m will be fixed from now on till the end of the problem, yeah, so I will have hard time to write this every time, okay? But you know L depends on it, okay? And then they have introduced another random variable Rn, and then this is x minus m ln. These two random variables are given in the problem, so I'm not adding anything to the problem. But again, because n is fixed until the end of the problem, I want to claim Rn. So L is the same as Ln in the book, R is the same as R sub m in the book. And then for that reason, I also claim this. Okay. Now, one thing we want to prove, what we want to calculate, determine the marginal distributions of these two random variables. And then we want to also show that these two are independent. Okay. Okay, what is your idea about that? Sorry, what was the question? The question is that show that, first of all, calculate the marginal distribution function. Let us concentrate on that. I want to calculate the marginal distribution function for this random variable n. Yes? If you have this question, it's very important how you think about the problem, so you need to know where to start from. So the first thing is that you need to understand if the variable is discrete or continuous, because there would be a little bit difference in how to proceed. Yes? So which one is discrete, which one is continuous here? Is L continuous or discrete? Discrete. It's discrete because even though x is continuous, this random variable is continuous, but when you put it in this floor function, are you familiar with the floor function? No, the floor function means the integer part. So for example, if you have 1, 7, you want to find the floor means the integer part. That's the meaning of the floor function. So in principle, it's important to remember this. If you have x, and I want to talk about the floor of x, if x is an integer, the answer is itself. So the floor of 5 is what? 5, because 5 is an integer. But if it is not, move to the left. The first integer you hit, you pick it up. That is your floor function, the floor value. Okay, so now let us start calculating. Because I want to find the marginal distribution function for this random variable, and I realize that this is discrete because integer and this floor function will only produce integers. There's nothing in between. Okay? So if I want to calculate that, instead of using the letter F, which is usually used for continuous ones, I will use P, L, and then I put my L value here. So I want to calculate this. This is the marginal distribution function for the L. Okay, help me. By the way, I don't know how to differentiate between little p. This should be a little p. Writing on the board. So how should I calculate this? I need to know the definition of this. What is the definition? It is defined as the probability of what? This takes that. Yes? Okay, but let us calculate this. And I told you that, you remember in the first lesson, I told you what is this in probability theory? This is a set. Okay, but it is written in this abbreviated form. So if I want to understand, if and only if this one, which is its definition, becomes L. Yes? But this itself happens, can you tell me if and only if? For example, if I tell you that the floor of a number x is 5, what can I conclude about this x? X is somewhere between 5 and 6. It might be 5, it cannot be 6. Because so that's exactly the same thing. Floor of something is L. This means that something, whatever it is a number starting from L, might be including L, but up to L plus 1. Yes? That's very important. You need to understand where to start from. So definitions are extremely important. And of course, everyone hopefully knows what to do if you have done your work correctly. I want to translate this, which I don't have any information about, to a statement regarding the random variable x, which I know something about. Okay? That's the idea. So what do you think? I will multiply everything by n, so this becomes nl less than or equal to x less than what? M n plus 1. Do you agree? Okay, so now go back. Instead of writing this, so I have to do this calculation. So you see, this is the logic I do. I start from the definition, then I ask myself, what do I need to proceed? Then I understand that I have to do this calculation. When I did that, I go backward again. So you should go back and forth. Yeah? So this becomes the probability of this happens. Yes? But that is very easy now. This is a very standard probability question. X is a continuous random variable that you see on the board, and then you want to have x somewhere between these two. So how should I calculate? I will calculate it as integral all over r from minus infinity to infinity. Why from minus infinity to infinity? Because the total range of that function is r. And then I have to write f of x dx. Yes? But from minus infinity to infinity is not needed here because this is only vanishing. It is non-vanishing if x is positive. Yes? Okay? So this means that I have to, in principle, I have to write from minus infinity to infinity. Sorry, from minus infinity to 0 and then plus 0 to infinity. But from minus infinity to infinity, this one is 0, so it goes away, and this will remain. Okay? So this, you don't need to waste so much time, but this is if you want to have a better understanding. So this becomes integral from 0 to infinity, and then I have lambda e to power minus lambda x dx. Yes? Yeah, please interrupt me if you don't understand something. And then this is a very standard problem. I can calculate it. What is the primitive function for e to power minus lambda x? Minus lambda inverted goes out, cancel that one, so I will get this. and I have to calculate it from 0 to infinity. I'm a little bit sloppy. In principle, I have to calculate the limit. Yes?
Where the boundary is not ML.
Yeah. Oh, yes, thank you. Very good. Yeah. So please correct me, okay? So this is from NL. Yeah, let me write this one first. No. Completely wrong. Yes. I have to start from here. Everything was wrong, so sorry. So ML plus 1. Yes, thank you very much. Please correct me whenever you see that I am making stupid mistakes.
Could we have done that and then afterwards insert those values?
No, because it gives you a number. And we're calculating that particular number. Yes, that's not possible. So I was very stupid. Sorry.
Will it not just be 1?
In general, yes, this will be 1.
Yeah.
So then it becomes ML plus 1. Okay, so I put them here.
That should be minus e to the minus lambda of x.
Yeah, this is this. Thank you. So let me concentrate everything. So it becomes e to the power of minus lambda ml minus e to the power of minus lambda m l plus 1. That's it. Let me make it a little bit more beautiful by factoring this out. So this will be 1. This will be minus lambda. Am I right? Can you confirm what I have done? Seems correct. But you know that the domain, what is the domain of the marginal function? The domain of every marginal function is the set of R itself. Okay? But I haven't talked about what happens for other values. So, but you have to, in principle, emphasize that it is 0, if that is not the case. So if you really want to write it correctly, so how can I write finally this one? Little p, L is equal to this expression, e to the power of minus lambda ml times 1 minus e minus lambda m. Under what condition, can you tell me?
And then greater than 0.
Integer and greater than 0. Greater than or equal to 0. Because n can in principle be 0 or not. Yes. If n, for example, let us say that n is, I think in the previous exercise they have mentioned n is greater than or equal to 2. So if that is the case, then it means that n can also take 0 as a value. Because if x is small enough, when you divide it by 2, it becomes, the floor becomes 0. So if you want to be precise, you have to write this if n is 0, 1, 2, 3, etc. Or that is the dotted line goes to that. And then 0 otherwise. You understand why 0 otherwise? Because you know that L can only take integers. When you say other, if L is not an integer, there is no chance for this to happen, so the probability is 0. But it is important. It is important to write this if you want to actually write it. So, because these functions are defined on the whole set of R. Okay, that's it. But the second one is a little bit more problematic. We have to be careful a little bit. So this is x minus ml. But you tell me, I want to do the same thing. First of all, you need to understand that this random variable is, because you want to find the marginal distribution. For marginal, you know that we have two notations, P for discrete ones, F for continuous ones. So if I want to calculate marginal function, I need to know which type of random variable I have. So here I know that R is a continuous random variable. You agree? Even though L jumps, but X can take any value. So in total, R can actually take all the numbers within the range. And if I want to calculate this, I have to do the same thing for the continuous one. Can you help me? What do you think I will write here? Instead of little p, I will write little f, yes. I want to write little f, and then I put R here, and then I put R here. This is what I want to answer. But do you remember what I told you last time? what is the standard way? This trick you have to have in mind, especially for the exam. It's extremely important to know where to start with. Even if you know, you might have problems still, let alone that you don't know. So if you want to calculate this for a continuous random variable, what was the standard trick? Yes, you have to calculate the cumulative one. So it means that I have to calculate capital F of R, yes, of R. And then why do you think it could, I just want refreshing your memory, why this is useful to calculate this? How can I go backward and find this? This is my question mark. Differentiation with respect to the variable, yes? So this is why. But then you have to remember the definition of this guy here. So what's the definition? The probability that your random variable here becomes smaller than or less than that given R. I'm just trying to tell you that definitions are extremely important. So memory is very important in learning. Okay, but then you have to do the same thing again. Instead of R, you take that one. So let me put it here. So it becomes the probability of x minus ml is less than or equal to R. But still I have to be careful. Might be for some R's this become 0, or for some R's, I don't know, it becomes 1 or whatever. Okay? But this one is a little bit problematic. If you have seen it in normal algebra and you have done it, if you are interested in solving math problems, it shouldn't be very hard. So have you seen this combination somewhere? You know something about it. This combination, let me just forget about it and let us discuss about this. So I will write x minus n instead of l. I am allowed to put that floor. I mean, this is a very famous function, by the way. Why this is famous in mathematics? This is one question. This is one possible answer. But there is another very beautiful answer to it. Why this is a good function? It's a good example. Yes?
X modulo M, right?
What?
X modulo M.
Yes, that is an answer in the realm of number theory. But let us say that I want an answer in the realm of calculus itself. You know a periodic function? Usually when I talk about periodic function, what comes to mind is trigonometric function. This function is not trigonometric but periodic. Okay, so remember that. So this is why it's good to know. And then it is good to see what the period is. That's a good exercise. Do it. You cannot sleep without finding the period tonight. Okay, be careful. This is the way that you have to think. So I factor m out. Then the reason I can't factor m out is because I am using my past experience, not because I am genius. Okay. So this is x over m, then this floor. Okay. This function is also famous. Can you tell me what is the range of this function? It is a number, so let me write it here. You have a box, and then you have that box minus its integer part. Yes, it will be a number between 0, might be 0 itself, and 1. Yes, so this expression is of this type, by giving the role of box to x over m. So that is exactly of this type. So this is somewhere between 0 and 1. Understandable? Yes? Because it's very easy to understand this law. But if a number is between 0 and 1 and I multiply it by n, it becomes between 0 and n. So this means that it means that my r variable is somewhere between 0 and n. The output of r is between 0 and n. For example, if I want to calculate what is the probability of r being less than 2m, what is the answer immediately? 1, because it happens definitely. And what is the probability of r being less than minus 2? 0. Yes? But the only problematic one is what happens if r is somewhere between 0 and m that I have to calculate. But it doesn't mean that you shouldn't include those things in your function, because this function has the domain whole r. Okay? So how can I calculate this? How can I actually go forward? my experience is that it is better to draw some graph for yourself. It's very good to know. By the way, x is positive, remember? So I don't need to worry about, I want to draw the graph of this function somehow. Yes? Y equals to, so let me not confuse. I want to draw the graph of this function. It is not very hard to convince yourself. For example, let me tell you something. If x is between 0 and n, what happens? If x is between 0 and n, x over n is less than 1 and positive, so the floor becomes 0. X over n survives, when you multiply it by n, it becomes x. So this means that if x is between 0 and n, this function is just simply x. So, and then drawing the x function is extremely simple, yes? So this is the x function, but I have to limit it between 0 and n. So this is y equals to x, but let us assume that this is n, and this one is 50. This is the possibility that I have, one possibility, okay? What is this angle? 45, that angle is 45, so these lengths are the same. But let us go to the next limit. What will happen? I considered the scenario that x is between 0 and n. So I considered what happens between 0 and n. Now I go between n and 2n. What do you think will happen? If x is between n and 2n, then this floor becomes how much? 1. And the function becomes x over n minus 1. But you multiply by n, it becomes x minus n. X minus n is the same line shifted here. Okay? So these are simple things. I just want to explain once completely, and then you hopefully agree with me that this will continue forever, yes? And then I don't draw this part because I know that x should be positive. Yes? Is the picture clear? But it will continue forever, and you can see it is periodic. It's repeating itself. Yes? Yes or no? Happy? Okay. But now, let me take r somewhere between 0 and n. Always drawing some pictures is good for you. So I want to restrict r between 0 and n. And I want to know what condition on x it imposes. Because the only thing I have in my hand is about x. I want to use the information about x to say something about r. So I have to translate something from r to x. Okay? And I have chosen r somewhere between 0 and n. Can you tell me what is this height? This function is y equals to x, and here is n. This one is also n. Yes, so this height is n. And now r is somewhere between 0 and n. For example, let us say this is my r. And then let me draw this line for you. Okay. I want to choose x so that r becomes between 0 and n, 0 and r. You understand? I want to know what is the limit, what are the limits for x, so that makes r between 0 and n. So can you see that this part is acceptable, yes? Because if x is from here to here, if x is from here to here, yes, do you agree that r will be between 0 and r, because that's the diagram of r. Okay, but this is not the only part. What is this length? Can you tell me what is this? If this is r, this is also r. So one possibility for x, this translates itself to a bunch of things that are union. Okay? So one of them is that x should be between 0 and n. Okay, so if you don't mind, let me just take all the zeros because these are my future.
0 and r.
0 and r. But this is not the whole story. What is the other one? The other one is here. Yes, but this length is again r because of symmetry. And if this is n, what is this number here? N plus 5. So then it means that the next one is r and n plus r. Do you see that? But is this the whole story? No, because there will be another one coming here. Yes? So what is that? 2n plus r, 2n up to 2n plus r, and then we continue. Okay? So this happens if and only if either one of these happens, and they are mutually disjoint. There is no overlap between them. Is that right? So I was able to translate this piece of information to something related to random variable x. Okay? So can you write this, for example, if I want to write this, in principle, I have to union, if I want to be precise, let me just put these equalities, it doesn't hurt me. So I have to write intervals of this type. So how can I write the general intervals? I would write it as kn plus r, but I union them when k goes from 0 to infinity. Do you agree with me? If I put 0, it becomes 0 to r, that is the first interval. If I put k equals to 1, it becomes between m and m plus r, which is the second. If I put 2, it would be the, so I have to union. So I hope that I could convince you that this is the union of these things, but for x. So might be that's not a good idea. That's not a good writing, sorry, because you don't see x here. But let me write it like this. X is between, what was that, kn and kn plus r. This is a better way of writing, and of course, let me write it use set period and copy. Yes. So now, if I go back here, if r is between 0 and n, I hope that you haven't forgotten what we are doing. We are calculating this. So p of r less than or equal to r will be the probability of this one. Yes? And these are disjoint, so that is one of the axioms of probability. What can I write? P of the union becomes the sigma of the p. Yes, so it becomes sigma. K goes from 0 to infinity. P of these events. Yes. No, but these are not very important because that one point doesn't change the probability. But this one, because when you say, I don't remember where did I write it. So if the integer value of x is n, this happens if and only if this happens. This includes, this excludes. Okay. But can I calculate these probabilities? Yes. So it becomes, let me put sigma here. K goes to 0 up to infinity, but what is this probability? This is again simple. That is the probability relating of x, and I know the probability distribution of this. So it becomes integral from the lower limit to the upper limit. But what I should calculate, I have to write the probability density function for x, which is that. So it becomes lambda e to the power of minus lambda x. Be careful, I am respecting this condition. Otherwise, my physics will affect this. Okay, then what happens? So this becomes sigma, k goes to 0 up to infinity. And then let us do this calculation. Let me calculate it in my head. So minus lambda cancel that one, there will be a minus. So it becomes e to the power of minus lambda km, and then minus e to the power of minus lambda km plus r. This integral is more or less identical to this integral. So if you're confused, you can look back. But again, I want to use the trick of factoring it out, because now my problem is to calculate this infinite sigma in series. Yes. So how should I do that? So I would write sigma, k goes from 0 to infinity. what can I bring out? So I can bring e to the power of minus lambda kn out. It becomes e to the power of minus lambda r. Okay, can you help me to continue? How should I calculate this sigma?
Geometric series sum.
Yes, what?
Geometric series sum.
Why? Because this is, I can pull it out, yes? In principle, if you want to be very precise, you have to first prove the convergence of this, then it justifies pulling it out. But because I know it's a geometric series, so it is convergent, so I don't have any problems. I will just take it out, and then this becomes sigma e to power minus lambda kn. K goes from 0 to infinity. I hope that everyone sees that this is a geometric series, because if I put 0, the first term is 1. If I put 1, the second term is e to the power of minus lambda n. If I put 2, it becomes minus 2 lambda n. So every time I am multiplying by e to the power of minus lambda n. So that is the common ratio. And then this is less than 1, so definitely this series is convergent. So what I can write this. Do you remember the formula? The formula is 1 minus the common ratio, which is e to the power of minus lambda n, and the first term after. The first term is 1. That's your probability. Okay, but be careful. I have limited the range of R, and this is for the limited range of R. But I told you, I am calculating capital F of R. By definition, the domain is the whole set of R. So you have to define the function on the set of R. But you already more or less answered every part of it. So, can you help me to write this completely now? So, if R is between 0 and n, don't worry, this is your answer. Which will be, let me write it up there. So, it's minus. Yes. And then there are, but this is limited. I have to extend it to a domain R, to the domain R. So what will happen if R is less than 0? 0. Yes, because I can hopefully convince you that this is your R. It does not go beyond n. It does not go below 0. So if you insist R is less than 0, so the probability to this happen is 0. But if R is greater than n, what happens? It becomes 1, yes, because if R is above n, R totally goes below the. So, and then you see that because this function is a probability function, should be continuous, and it is, hopefully, otherwise we are in trouble. If R is m here, you see this becomes 1, so it's continuous. And if R is 0, this becomes 0, that's continuous. These are good checks. That if you don't have them, then you are in trouble. So when you go back and see.
Wait, why was it 1?
This one? Because if R is greater than 1, it means that instead of choosing R here, if R is greater than n, instead of choosing R somewhere here, I am choosing R there. And you see that all the support of this R is already below. So the probability of this to happen is always 1, certain. Is that right? So you see, I am looking about when R is less than R. This is the diagram of R. And if R is already here, what is the chance that this is below this level?
Oh, it's 1.
1. And if it is here, what is the chance? 0. Yes? But, okay, let me review. Why did I do this? What is the next step? You need to tell me. Differentiate, very good. That's why. So why I want to differentiate? Because the question was little f. So I want to go from capital F to little f. So this means that f of R is equal to the derivative with respect to R of this. Okay, so what is the answer? Very simple. So here the derivative is 0, here the derivative is 0. So I am relieved a little bit. I don't need to write so much. So I would say that if R is between 0 and m, this one, yes, this is a constant with respect to R, so let me just write it. But the derivative of this one with respect to R becomes lambda e to power minus lambda R, and 0 otherwise. thing that we have to do now, so I don't know, this is just one problem, okay? Let me give that one as an exercise. This is the first part of the problem. The second part, we want to prove that these random variables are independent. So how should I do? It's more or less already done. Because one of them is continuous, one of them is discrete. So if I want to show that these random variables are independent, I have to show that this probability is equal to the product of these two probabilities. Okay. In principle, you shouldn't have any problems here, because this I calculate. Oh, sorry, I have to write. Yes. These are capital P's. It's very hard to distinguish little p and capital P in handwriting. So these are probabilities. Okay. So this is on the board actually. It is capital F of R. This is your probability. And this one, we already calculated that. It is here. Okay. But there are some delicate points, but because I want to continue with other exercises, I want to give this as an exercise to you. So this one you shouldn't have any problems with. The only thing you need to do, you need to multiply the function that I got here and that function. But one question I want to ask, how many situations you need to consider for that multiplication? Because here, this depends only on L. We don't see any track of N here. And then in this function, you don't see any track of L for the support. You only see N. And you want to multiply them. So you have to be careful about, for example, can you tell me when it is not 0, when that product is not 0, if L takes this and R takes that, okay? But then you have to consider that L takes that one, R takes this one, L takes that one, R takes this one. You have to consider all cases. But that's not hard. So this right-hand side, it's already done. You just need to sit down and multiply. It's on the board. But this one, I want you to do it from what you learned, and what I did here. In principle, you should be able to calculate this one yourself. This comma means what? This is a set, that's a set, so it's an intersection between two sets. So if you learned what I told you here, in principle you should be able to calculate this probability yourself. If not, I don't know, if I can find a way, there are some studios in KTS, if I can book them, I will record them for you, okay? But I cannot promise them. Okay. Any questions here? Do you want to rest? 5 minutes, okay? We want to show that the expectation value of multiplying this random variable by a function of that random variable h becomes equal to lambda expectation value of h, but calculated at what unit more, 1 unit more. Very simple. Okay, so this translation, you need to go to the back of the book, but Poisson is also famous. I have it in my memory. So P. This means P of x calculating at k, it becomes e to power minus lambda to power k divided by k factorial, and k goes from 0, 1 to 2. When they say it's a Poisson distribution, in the back of the book, you need to find a table, and this translates itself to this. Okay, but now let us start. From the left-hand side, I start. So this is the expectation value of a random variable. It's a random variable. If h is it's mentioned it's a Borel function. If it's a theorem, it's in Koski, I think. If h is Borel and x is a random variable, the composition will be again a random variable. And if you have two random variables, the product will be still a random variable. So this means that this is well defined. So, but then it means that you need to write a formula. So can you help me? Expectation value, by the way, what kind of variable is it? Discrete. So it means that I have to start with the sig. And then can you help me to write the formula? Push your brain. Yes.
So the k goes from 1 to
For expectation value, you have to put all the support, all the values of the support of your random variable, multiply them by the corresponding probabilities, and add them up. That's the meaning of expectation.
That's the first one, 0.
If you don't mind, let me write it and then explain it, okay? So, k goes from 0 up to infinity, so I sum it up, and then this x and that x are taking values, k values. K can be 0 up to etc. So I will write it as k, h of k multiplied by p x of k. I am doing nothing. If you don't know this, you have to go back and study. This is the definition of expectation value. I've written the formulas. But then it is clear what to do more or less. First of all, let me actually, this is very helpful because even though in principle I have to start from 1. Okay, is that okay? So I start from 1, infinity. I copy and paste these two. But of course you know what to do. What should I do? Instead of this guy, I put its formula. So it becomes e to power minus lambda, lambda to power k, divided by k factorial. That's it. And then, whenever you want to prove something, this gives you some hint or some guide. You know, here, h is not acting on x, is acting on x plus 1. So what are the possible values for x plus 1? The possible values for x plus 1 will be k plus 1, because the values of x are k. So that's already an indication what to do if you already have experience. So what do? You want to make this k is not good for you because you know what you want k plus 1. Then you need to ask yourself, what do I have in my toolbox for changing k to k plus 1? That is, if you ask this question, and if you have previous memory about them, it will come immediately. So what should I do? I want to make this k plus 1. Change the sigma limits. How? I start from 0 again, so this becomes sigma. I start from 0 again, but the price will be adding 1 unit to every k inside the sigma. So this becomes k plus 1, hk plus 1, and then e to the power, k equals to 1, e to the power of minus lambda, lambda to power k plus 1 factorial. But this could be completely random. If I didn't see that, I wouldn't even probably have noticed that I have to do this. But looking on the right hand side already gives you a hint. Okay? And then what is left? It's very simple to see what I should do. You know, I need a lambda here, and then I have an extra lambda there, so pull it out, okay? This is a weak lambda. So when you want to start killing someone, you start with simplest, the weakest one. So k plus 1, and then I would write h of k plus 1, and then instead of lambda to power k plus 1, I just write because I put lambda out. And you know what to do with this k plus 1 factorial, yes? I can write it as this k factorial, and then k goes from 0 to infinity. Yes? And then what happens, this extra k plus 1 that I hated is gone. Calculated not at k plus 1, and there should be some mistake. It's e to power minus lambda should also be there. So let me write it here. So then it becomes e to power minus lambda times lambda to power k, and then k factorial. But what is this? This is just p of x of k. Yes? So you have your lambda here, and the whole sigma written in this form is the definition of expectation value of yes? And that is your right hand. But that was easy. So the next one is, if you have questions, please let me know.
Sorry.
The next one, yes,
Possible to ask, when you're writing the sigma from 0 to infinity, then you transition to another sigma from 1 to infinity. How did you make
because the
that
first
transition?
one accidentally is 0.
Ah,
When you open up the sigma, you have to put k0, k1, k2. When you put k equal to 0, even though it is there, but the first term is 0. So it doesn't matter, you can start with 1.
wouldn't it be just faster to then say k is equal to 1 immediately, or do we have to say that because of the convention?
May you repeat, please?
Wouldn't it be faster to simply write it immediately as k is equal to 1 rather than k is equal to 0, or do we have to?
No, I am obsessed with precision.
Okay.
So, because if you write it from there, it means your definition is that. That is not your definition. Definition starts from 0, but for some reason, we don't need 0. So that is the motivation. Okay. So here, if I go to problem 6, that is very simple.
So,
They have
sorry,
given
I have a question
Yes.
also. The second sum sign
Here,
shouldn't like lower k equals 0 there.
that's the same question.
Okay.
K equals to 0, it accidentally becomes 0. You see, when I want to open up the sigma, I have to replace k with these values. But when I put 0, because of 0 multiplied by something, it becomes 0. What I am saying is that for this case, sigma k goes from 0 accidentally becomes equal to sigma k from 1. Because the first term of the sigma is 0. Understandable or not?
Yeah, sure.
I'm sure that you're not happy, but we can discuss after
Yeah,
this.
sure.
Okay. Yes. I can read your faces. I have been teaching for 35 years, so I can immediately guess you're not happy. But I have to a little bit go forward. So page 89, and then what happened? This is also a good question. I hope that you can immediately answer that. Of course, they have given you the hint. They have given you that this x is the Poisson distribution with parameter lambda, exactly as before. But you are supposed to calculate the expectation value of x to power n and prove that this becomes sigma. K goes from 0 to n minus 1, and then n minus 1 choose k, and then expectation value of x to power k. This is what we want to prove. This is the problem. I mean, if you have the book in front of you, if you go to that page, you can see that these are in the problem. And they have given you a hint here, use the previous problem. They have mentioned, use the previous problem to prove this. And, I mean, without that hint, my think was not that obvious. I don't know, because I immediately saw the hint, so I was able to solve it. I'm not sure if I could immediately solve it if I didn't see the hint. But do you know how to proceed? Hint is in front of you. If you want to use this as a hint, hopefully you agree with me, this is going to play the role of this one. Yes or no? Or at least this is one possibility. If this is going to be the case, you need x multiplied by something. So then immediately it becomes clear what is that something. What is that something? X to the power. So what I will do, I will write from the left hand side, it becomes the expectation value of x times x to power n minus 1. I want to give the role of h to this in the previous problem. And then I write the formula for myself here. So it becomes lambda. So it becomes lambda multiplied by what? Expectation value of what? Of h x plus 1. Yes? If you don't mind, what is h x plus 1? It means replace x with x plus 1. So it becomes what? 1 plus x to power n minus 1. If someone asks what is this, this is h of x plus 1. Yes, do you agree?
Yeah.
Okay, then what? Still, in my problem, this is the way you have to think. You need to reach to a sigma. So far, I don't have sigma available. So how can I make sigma appear? These are the right questions to ask to help you to go forward. So what is the right way to bring sigma in my problem? And then look, sigma is no longer a series. It is just a finite sum from 0 to n minus 1. And n minus 1 is an indication what to do. expand binomial theorem. It's the binomial theorem, yes? What is the binomial theorem? It's A plus B to power n is sigma, n choose k goes from 0 to that power, and then we have a to power n minus k, b to power k. Yes? This is binomial theorem. Even if you don't know, you need to know binomial theorem, not by heart. You need to know once upon a time that there was a binomial theorem. So when you need it, if you don't have it in your memory, you go back and find it. At least you know where to find it, yes? Okay, but now can you help me to write this one here? So I am giving the role of A to 1. That was intentional. I wrote it the other way. So that I want to give the role of B to this guy, and I want to give the role of capital N to n minus 1, and I use the formula. So what will be the formula? Sigma k goes from 0 to capital N, but capital N in this problem is n minus 1. Capital N is n minus 1, choose k. A is 1. So 1 to any power, forget about it. B is x to power k. Yes? Okay, now I put it back. So this goes expectation value of this random variable, but I expanded that like this. I think that would be a matter of 1 second to understand what to do next, yes? So, how can I go forward? So if you don't mind, let's do. How can I go forward? I copy and paste lambda. E of a sum, of a finite sum. You know that E, one of the main properties of expectation value, it is linear. So I can expand that. Linear means what? Linear means that if I have A acting on X plus a constant acting on another variable, I can write it as E, A, X plus B, E, 1. Yes? That is the meaning of linearity. And then here, I have more than 2 terms. I have n terms. Yes? So it becomes what? Sigma k goes from 0 to n minus 1. These are constants. They are playing the role of these constants A and B, so I pull them out. And then this expectation will hit this random variable. Isn't it what we want? Yes? That's what we want. Any questions? Understandable? So the other one, I think we don't have one of the obligatory ones here, so we go to page 104. But I think you have already seen that in your probability courses. Do you know the formula for the total probability? Yes. So, for example, if I have, let me see which one. Let me write the number here. At least I can explain it. It's very simple, by the way. I want to use the same notation in the book. This is problem 3. Page, what is that? Page 104 of the same lecture notes. And then they want you to prove this probability of an event E can be written as sigma probability of B conditioned on these events AI, PA, so P capital P, AI, I goes from 1 to n. Okay, so let me tell you what this is. AI is A1, A2, up to AN for a partition for the sample space omega. What is the meaning of partition? None of them is empty. There is no overlap between any pair of them. And the union of all of them is the omega. So if you want to feel it, it seems like this. If I have this my omega, something like that. Something like this. For example, A1, A2, A3, A4, A5. Okay? And then what is B? B is any event from this probability space. This is B. Okay? This formula tells you that Now, imagine in your head A1 up to A4 and A5 are faded. Don't look at the A's, just look at this red boundary. That is an event. You want to calculate the probability of that event. No condition is there. In the beginning, that is just a normal probability calculation. But this formula is very useful because some probabilities are hard to calculate. If you start conditioning them, then each part can be calculated simpler, and then you can add them up. That's the idea. You have this event, you don't have these partitions first, you want to calculate this. One way is, of course, tackle the problem and calculate this impossible, but one very useful tool is to start conditioning the probability, even though the starting probability is not conditional at all. Okay? So we want to prove it, but it is important. You cannot just condition on any set of events. The events should be a partition of omega. If the events are partition of your omega, then you can write this total probability for it. Okay? And the proof is extremely simple. It's just a matter of 1 minute. Okay? So let me start from the right hand side. Okay, help me. What do you think I will do? What I will do? You are supposed to think about the problems just before coming. So, what I'm supposed to do? The formula for this, yes. I start from right hand side. What is the formula? PB intersect AI divided by PAI multiplied by PAI, yes? This is, but this one and that one are gone. And then it becomes what? Sigma P of B intersect AI. AI goes from 1 to n. Okay, but what kind of events they are? Do you see that these events are disjoint, mutually disjoint? Why? Because if I take B intersect with AI and take it with another one, let us say J, if I is not equal to J, then what is the intersection? This will be B, B intersect B is B, then it becomes intersect AI in J, but according to the condition, because this is a partition, it is empty, so it becomes empty. Yes? So this means that I can write it as P of the union of these things. Yes, this is the probability axiom. Okay? But what can I do here? No, sum it up goes back to this one. Yes. It was already in the form of sum. I wrote it as the P of union. But this is simple thing to do in set theory. Yes? How can I write it? So this means I am unioning all of them. So let me write two of them, for example. If I give you this union, and then I continue this list, you see B intersection is in all of them. By distributivity, I can pull it out. So what happens? It becomes B intersect A1 union A2 union, etc. So this means that if I want to write it, so it becomes equal to, so let me put this in the box. So this becomes P of, how should I write it? I pull B out, B intersect, and then union AI, I goes from N1 to N. Yes? So can you tell me what should I do now? Remember, I told you it's a partition. If it's a partition, you know something about this, which is omega. So this becomes P of B intersect omega, but B intersect omega is B, and that is your left hand side. There is a very extremely beautiful problem, which is a recommended problem. I don't know, should I first solve the obligatory ones? But I would recommend you at least think about this problem by tomorrow, and I detected the typo there. It's problem 14 on page 160. I want you to think about it because this is not something new. This is probably you know from your previous course, but you will see how this is useful in solving problem 14 on page 106. If you think about it, we can go through it tomorrow. I mean, if you have time, I could probably take do it now, but I don't think so. So, if you want to see a very beautiful application of this formula, do this exercise, which is in the recommended list problems. It's a very beautiful problem. Let me also detect the type. The type, yeah, it doesn't have any memory apparently. Yes, it loses the memory. So it doesn't only care about the value. Okay, but this is very simple, yes. So how can I solve the problem? So I will start from the left-hand side. Okay, help me. How should I do that? Can you do it now? Because I think you are a little bit tired. That's why you are just listening to me. Do a little bit of work, and you'll become active. Everything you need is on the board. This is very important, by the way. In mathematics, when you see a problem, usually hard problems, I mean Olympiad problems we have seen, it doesn't matter how much hour you sit down and think, you will not be able to solve it, okay? Because they are you have to be extremely creative. By the way, ChatGPT 5 can actually won the gold medal, yes. So, and I saw the solution, it was astonishing. Correct. Okay, so I don't know what we're supposed to do. You need to find a way for yourself. I'm 52, I have the problem getting close to retired and I'm jobless. Okay. So, yeah, but then everything loses the meaning, yes? And are you engineers? If the problem is on you, you have to blame you, yes? Why did you do that to us? Anyway, so if I want to solve this, you know, this is not being very creative, this question. So for example, if you see this, I know exactly where to start with. If there are some surprises, after a while I get to stop. Oh, this method I knew didn't work. But you shouldn't get stuck in the beginning. If you get stuck in the beginning because you haven't respected definitions and the methods and things like that, yes? So when I see this, immediately I see what is this guy. It's very important, names, yes? If I ask you what is this in mathematics, you will say it is a probability, but can you specify more? Yes, it's a conditional probability. Where something in my toolbox I have about probability. This is the method you have to think and go backward to find something. Okay? If you don't respect this, if you respect that, sooner or later you will learn. And you know mathematics is hard even for mathematicians, so don't make it even harder. Okay, so these things you can learn, believe me. Okay, so I see that this is the conditional probability. I go to my toolbox. I need the definition. I need to know what this is. I want to prove this is equal to this. I need to know what this is in the first place. So it's a conditional probability. And then I have one definition of conditional probability. We just use that. Do you remember? If you don't remember, of course, you can of course go and look for it. You cannot teach a 100-page book to see which one is useful. You need to have a goal. So this is your formula. So what I will do, I will start from the left-hand side and write P of x greater than s plus t. Of course, I need to put intersection, but because I have written it in this form, what do I put usually? Comma. Comma means intersection between these two sets. So x greater than s, and then divided by what? P x greater than s. Yes? And this is the simplest, but there are two things that I have to calculate. I have to calculate the numerator, I have to calculate the denominator. I always start from the simplest one, yes? Because I will actually feel confidence to continue. You tackle the hard one, then you don't know what to do, okay? But at least this one is easier to calculate, okay? So I will start from here. So how should I write that? This is a very standard probability problem. This is given, and I want to have it greater than s. So it goes from s up to where? When I, yes, y infinity, sorry, this one is also x. Sorry for that. Yes. So this is up to infinity. Why? Because I see that x goes without any bond from right. So it goes from s. Why from s? Because I want to start from s, but there is no upper bound. So I have to go until it allows you. And then I put 1 over lambda e to power minus 1 over lambda x. If you don't mind, let me write it like that. But these are very standard integrals, so the reciprocal of this will be multiplied here, cancel. So it will be minus e to power minus 1 over lambda x, and I have to calculate it from s to infinity. And a little bit sloppy, you have to write to something and then say the limit, but that's very simple. Okay, so if I put infinity, what happens? Lambda is positive. I haven't mentioned, but it is mentioned in the book. That the parameter is always positive. So this is negative, x negative, so it becomes 0. And then I put s. So it becomes e to power minus s over lambda. Okay, how many of you got this for the denominator? Okay, congratulations. Yes, but you have to answer the questions again. Yeah, you know what happens? You have to enjoy.
I'm sorry,
Yes.
doesn't it become 1? The power becomes e to the power of 0.
Yes.
So
Yeah, very good that you correct too. Yes. You see why? Because if I put infinity, it becomes 1.
and then
No, you are confusing me. Because this is e to the power of minus infinity is 0. Yes.
oh sorry.
Yes. Yeah. You know, Nietzsche says that probably there is not that much meaning in this world. All we can do as this, we have to give our meaning to the life ourselves and project it into this damn world, and it gives you meaning, you know. And this is good, you know. I can be happy with very simple things. So I have some meaning I have projected here on this classroom, so I am enjoying what you are hurting, you know. So that's the difference. Because the way I look to the world is different from the way that you are looking from it. Yes. So I cannot wait until the next lesson that I come here. That's good. Then that's the meaning. I mean, I can go home and I'll be happy, and I come back happy. Okay, with a piece of chalk and everything, so something very simple. Okay? So these philosophers are, by the way, coming from West. I need to study them. So I don't know. Anyway, so we want to calculate this. That is correct. Then we go to this one. This one, how do you think about the problem? You have a lot of experience. This is the simplest one. You want to have, on the one hand, x be greater than s plus t. On the other hand, you want to have x greater than s. This is very common. Normal people talk a lot. But if you are a mathematician, you shouldn't do that. Instead of saying that x is greater than s plus t and x is greater than s, yes, you have to be lazy in words if you want to be a good mathematician. So what do you say? Greater than s plus t. Yes? Because if x is greater than s plus t, you already covered this one as well. So why should I say something 2 times? Yes? So you have to be very economical. So p x greater than s plus t and x greater than s means p x greater than s plus t, or t, yes, s plus t. And then you calculate this. So how do you calculate? The same story. So it goes from this time s plus t, yes, that's the same story. You don't even need to calculate, do I? Yes, because you see that the only difference, let me write at least the first part. What is that? 1 over lambda e to power minus 1 over lambda x dx. Okay, and then if you compare this integral with that integral, it's exactly the same. The only difference is that s being replaced by s plus t. You can also do this, or if you really enjoy it, you can do this again. So what happens if you come e to the power of minus s plus t divided by lambda? Are you with me or not? Yes?
Do you know that t is positive?
Yes, they have to mention, I think. They haven't mentioned these things that much. No, they haven't mentioned, but I think they should be. Otherwise, if s is not positive, what happens for the numerator? Then there would be a big problem. You are right. Yeah, I am solving it under the condition of s and t be positive. If s is negative, what will happen?
X has to be positive.
If t is negative, I am in trouble, yes? S doesn't matter that much, but if t is negative, then it will be the other way around, yes? So you can probably, yeah. Yeah, but because they have talked about loss of memory, so I think we are going forward, not backward. Yes? So I think that t should be positive, so that this time is after that time. And then it makes sense, because they have mentioned that this is known as the lack of memory property of the exponential function. Yes? Yeah, I think
Does that even, like, that doesn't even hold if we don't make that restriction, right? So then if it's not that, then we're asking us to prove something that isn't necessary. Like, does that hold if s and t is whatever?
Do you not just change variables and like make it positive?
okay, but let me think about it. You can also think about it yourself. Yeah. But you are right. This I am assuming that t is positive. Otherwise, this is not good. Okay. But you can consider the other. So let me put a question mark. You can also think about it. So you have something to think before saying yes. Okay. Now this one is done. The other problem is also a good one. If we can, so we can more or less cover everything, at least the mandatory ones, if we can solve this one as well.
You still need to prove the right hand.
Yes. But the right hand side is also simple, isn't it? So let me divide them. Yes, the left hand side and the right hand side. This one I put it on top, and then I divide it by this one. Yes. Do you agree it becomes what? Yes. But that one is exactly the same thing, but instead of s, I have t. Do you agree? That is exactly equal to p of x greater than t. And that is equal to the right hand side. Yes? Okay. So now let us go to the next one. The next one is more interesting, I think. Problem 13. This is the last compulsory one, I think. Problem 13. Page 106. So x is exponential with parameter 1. Y is also exponential with parameter 1. And they have mentioned that x and y are independent. Do you know that this is in probability IID? Have you seen that? In text it means that they write x and y are IIDs. It means that they are identically distributed and they are also independent. So sometimes you can see that. Okay? IID means independent and identically distributed. Something like that. Okay. So these are, they have mentioned that x and y independent. We want to calculate this. Find the distribution of this random variable so that c is positive. We want to find the distribution of this random variable where c is positive constant. What does it even mean? That's why it's very important. This is the role of your memory. What you have studied, now you want to apply it here. So these are distractions, so don't forget about them momentarily. So if I want to calculate this, you need the definition. So you want to calculate this. Have you seen it in your book? This is the probability, the conditional joint probability distribution. This will be a function of x. This is what is wanted. Okay. So this question in English, they are asking about to calculate this. Okay, but do you have the formula somewhere in the back of your head? So for example, if I have f of x, z, capital Z is equal to little z. This, how is it defined? First of all, it's a function of x, and then it becomes what, do you remember? it becomes the joint distribution between these two, calculated where x is this x and z is this little z. Yes? Divided by what? F of z calculated at c. So you see again, if you don't know that, what do you want to do? So you have to ask yourself, when they are talking in English about finding the distribution of this, in mathematical symbols they mean this. And if I want to find this, let me page the book to find something similar to this. And then you see that this has a very not similar structure, because you don't find this formula in the book, but you will find this formula in the book for y. Okay? But because y is already used, I use the letters. So you see that this is comparable to this example. Okay? And then in order to answer the question, can you write it for me now? Can you write it for me in that formula? What happens? So give the role of z to this guy. So what happens? So f of, so this becomes equal to the fraction line, f of x and z, if you want to, of x and c divided by f of z and c. Yes? So I am using this definition. This is the definition I am using, but I am fixing it. I am tampering this a little bit so that it fits with my problem. Yes? So then it becomes clear that I have to calculate this and calculate this and then divide it. Okay? So, do you have any idea how to do? This one?
Yeah.
Yes?
Since x plus y is equal to c, then we can write it as the joint distribution of x and y with the input of x and c minus x.
Yes. So let me follow you. So you are telling me that f of x. So don't write it down. If it works, then we can write. So this is what you're saying. So what should I do?
Right, f of x and y.
This?
Yeah.
Yes.
And then first input is x.
Yes. Little x.
Yeah. And then c minus x.
Okay. So can you justify it?
Yeah, since x plus y is equal to c.
Yeah, that is not wrong. Okay. But I want you to be 100% sure. That is exactly the lesson I started with. Do you remember? So you want to calculate. So you see here I have f of x and x plus y. Yes. You remember I told you. So you take u to be your x, and take y to be your your v to be x plus y. Okay? And I want to flip from x and y to u and v. Okay, this is the best. Might be at the end it will give you the same result as you are getting, but I'm always become very confident if I really start from tangible things, you know. So I will start from here, and then I will try to answer this question: that what is this expression? Okay, so do you remember what I told you? So this means that x is u and y is v minus x, so it becomes v minus u. So let me write little. Okay, so do you remember we have to calculate the Jacobian? So derivative, let me write it fast. Derivative of this one is 1 with respect to u, with respect to v is 0. Derivative of this one with respect to u minus 1 with respect to v is 1. I take the determinant is 1, and the absolute value is also 1. So what I can write that f of u and v calculated at u and v is equal to of f of x and y, but calculating u and v, I have to write x and y in terms of u and v. So it becomes u. Do you remember I started with this today? Okay, and then absolute value of 1 because this one is 1. Okay, but how can I continue now?
If they are independent, just use the current formula.
Yes, x and y are independent. Whenever it is independent, what can I do? I can write f of x of u multiplied by f of x by v minus u. So what I did, I'm doing the same thing, you see, over and over again. So I have changed the variables, and I changed this one to this one, and then because I know x and y are independent, I can write it as this. Okay, but do you remember the support is also very important. So what are the supports for x and y? These are exponentials. Exponentials support is this. So it means that x is positive, y is also positive. So what happens? So this becomes equal to, let me write it like this. F of x of u, let me write the exponential here. This means that f of x is what? Because lambda is 1, it is e to power minus x if this is positive, 0 otherwise. That is the meaning of this. Something similar for this one as well. Okay? So what can I write here? This becomes e to power minus u. If what? If u is positive, otherwise 0, multiplied by this function. The same story for this one, but this one is minus y. Okay? So what happens? It becomes e to the power of u minus v. Can you tell me what should I write here? What should I write here? Because y is also positive, so u is less than v. Yes? So if I multiply them, if I multiply this by that, it becomes e to power minus v if 0 is less than u less than v and 0 otherwise. Are you with me or not?
So what happened with the input C when we have f of?
No, I will put C later. Sorry, yes.
C
C is a fixed number. Yes, I am calculating it for every v. That's the meaning of finding the function. And then when I have the function is in full form, I will take it and put the C, which is a constant given in the problem. I'm not allowed to change it. But this is variable. Yes. So I was able to find this for all possible choices of u and v as variables. But now I know that I want to calculate this. So now can you tell me finally, what is f of x and z of x and c? What is that? X is your u, z is the same as v, x playing the role of u, and c is playing the role of v, which is acceptable positive. So it becomes what? It becomes e to power minus c if 0 is less than u less than c, and 0 otherwise. Yes? Understandable? We can discuss about it after the lesson is finished. I will not erase it. But then, everything is simple. What can I do with this one? What can I do for this one? It was very standard. Marginal function. So you have to integrate this over the other variable. Yes? And then you get this one. Okay? I know the lesson is finished. Okay? I want you to, I will continue tomorrow. We have some more. Okay? But please, before sleeping, at least think about them. And take some notes so that you can actually write this. So at least more or less we were able to finish every obligatory one, but the recommended one are more fun. If we have time, we can actually go through them.